Okay guys, it's me Imad from Nelson Darwin Park Tech YouTube channel. So in this video tutorial we will learn about how to simulate a circuit for the KCL implementation or proof. So for it, first of all, we must know that what the KCL or Kirchhoff's current law states that. So simply KCL states that if there is a node means a point where two or more electrical or electronic components used to meet. So all the currents entering to a node is always equal to the all the currents leaving the node. Like if 10 ampere current is entering the node, then 10 ampere current must be leaving out the node. So for it we need, first of all, we need to take our components. So we will go in library and we have to select virtual instruments, and then we will take our what's called is the ammeter. Why it is so? Because ammeter is used for to measure the currents. So this is our ammeter. We also need some components like resistors. Okay, these are our resistors. Okay, now we need our power supply because we need a current source as well. So we will go for 9-volt battery. Okay, now we will see that either it is we are able to verify the KCL statements within the circuit wizard or not. So we can see that now this is the fact. Now we made a node where three components are attached. So this our what's called is the node. Okay, now this is our node. So we know that current used to move from positive end of the battery to the negative end of the battery in this direction as per the conventional rule is concerned. Then we can see that if there is some current entering into this line coming to the node, then it will distribute on two lines. Some current will go to R3 while some will go towards R2. So we will see that either we have equal amount of current flowing all. Now this we also need to what's called as the put one ammeter here, so we can control and copy, we can like move it out, positive and this. Okay, so one more. Okay, so this is our now we will run it out. Now we can see that our first ammeter is showing 6 milliampere because it is the current entering into the node, that is 6 milliampere. Then we can see that 3 milliampere used to flow towards 1K and 3 milliampere used to flow through this R2, that is 1K. So if we use to add them, 3 milliampere and 3 milliampere, it is equal to 6 milliampere. So in this way our KCL law is proved via this circuit. So hopefully you got the concept. So thanks for visiting our channel and don't forget to subscribe.